Chem Gang. In this video, I'll be working through the solution for Skillbuilder 11.8, and that's where we find molar mass using the ideal gas law and mass measurement. So first of all, I like to write down what I'm given. I have a sample of gas that has a mass of 827 milligrams. So my mass is 827 milligrams. I'm going to have to convert that to grams in order to use my ideal gas law. My volume is 0.270 liters, and that's fine. At a temperature is equal to 88 degrees Celsius. I'm going to have to change that to Kelvin. And finally, I have a pressure of 975 millimeters of mercury, and I'm going to need to change that to atmospheres. I am going to need to find molar mass, and molar mass is equal to my mass in grams, which I have here, or will have here, divided by the number of moles. So I don't have moles, so I'm going to use the ideal gas law, which uses pressure, volume, and temperature to find moles, which is that N value. So find the moles, use that and the mass to find molar mass. That's the path that I am going to use. So first of all, I need to do some conversions. So milligrams to grams, there is 1,000 milligrams in a gram. So if I divide by 1,000, the number of grams I'm going to have is 0.827 grams. So that's been converted. My liters are fine. My Kelvin, so to switch from degrees Celsius to Kelvin, I'm going to add 273, and that's going to equal to 361 Kelvin, so that's converted. And lastly, to convert to atmospheres, I know that I'm going to multiply, and I know 1 atmosphere is equal to 760 millimeters of mercury. My millimeters of mercury cancel out, and I get 975 divided by 760 is equal to 1.2829 atmospheres. So that's my first step, is just to do any conversions to get to my base units. Next, I'm going to use this ideal gas law to find out my moles. Now, the ideal gas law is that pressure times volume is equal to moles times my ideal gas constant of R times my temperature. So I'm going to go ahead and just plug in everything except for N, because that's what I'm trying to find. So my pressure is 1.2829 atmospheres. My volume is 0.270 liters. That's equal to N, which I'm trying to find, times my ideal gas constant, which is always the same, 0.0821, times my temperature in kelvins, which is 361. Before I isolate N, I am just going to simplify my numbers. I'm going to multiply 1.2829 by 0.27, and that's going to give me 0.3464. Notice that I try and keep as many decimals as I can. I don't round until the very end. And now I'm going to multiply 0.08121 by 361, and that's going to give me 29.6381. So I'm combining like terms. This is an algebra notion. Next, I'm going to isolate N by bringing the 29.63 over. This is an 8. And to do that, I have to do the opposite operation. So what's happening between N and this number? We're multiplying. So the opposite of that is dividing. And whenever I divide a number by itself, they cancel out. It becomes 1. And whatever I do to one side, I must also do to the other side. So N is going to be equal to 0.3464 divided by 29.6381, and I get 0.01169 moles is equal to N. Now what I'm going to do is use those moles in my molar mass calculation. So molar mass is equal to my mass in grams, which I found it here, 0.827 grams, divided by my moles, which is 0.01169 moles. And so my molar mass is going to be 70.7 grams per mole. And that's the answer to Skillbuilder 11.8. Thanks for watching. Bye for now.